Hello guys, welcome to Free Shiksha. Today we are going to learn some advanced topics in gravitation. So first of all, we will learn the acceleration due to gravity, the change in acceleration due to gravity because of the rotation of the earth. What we have studied till now is what is the acceleration of gravity on the surface of earth above some height and at some depth. Now because the earth is rotating, there is some effect on the acceleration due to gravity because some centripetal forces also acting in this picture. See, the earth is rotating and hence there is a centripetal force acting on this object which is placed on the earth. Now we will take into consideration that also. Previously we had not taken that into consideration. So acceleration of m with respect to the earth's center O is r cos theta omega square. Simple general formula of acceleration when an object is in circular motion is r omega square, isn't it? R is the distance from the center of that circle. Okay, so now we will take this as the center and this object is moving in this circle, isn't it? So this is the center. So we need to find out what is the distance between the center and this point. That is what in the normal equation we write r omega square. So this is r, this is that r. So this is nothing but radius of earth into cos theta. We have already taken theta here. So r cos theta omega square. This will be the acceleration. This will be directed towards this center. Fine. Axis of rotation. Fine. So now if we write a free body diagram on this object, what is going to happen is we want to resolve all the forces in the direction that is towards the center, that is this direction, and towards we just want the forces to be resolved in this direction and this direction. So we know there is a centripetal force that is acting and there is a force mg on this. Very simply mg we will put because it is getting attracted due to earth's gravitation, and there will be a minus force, that is what centripetal force will act in this direction, and because this angle is theta we know, and hence what will happen is there will be a force in this direction. I mean, we are resolving it in this direction, so therefore centripetal force resolved in this direction will be nothing but mr cos theta omega square cos theta. Why cos theta? Because this angle is theta and the centripetal force on in this direction is mr cos theta omega square. Fine. We knew the acceleration in this direction, we just had to multiply that with mass to get the force in this direction, and then we resolved it in this direction. So all the forces need to be resolved in the line towards the center and joining the object. So this is the force Fn. We can take m as common, and now we get Fn upon m is equal to g dash. There is a change in gravitation, so what that will be equal to g minus of r omega square cos square theta. So where g dash is the apparent value of acceleration that is experienced, because I mean this g will be experienced by the object, g dash. So at poles where theta is 90 degrees, g dash will be equal to g, and at equator theta is equal to 0 degrees, so g dash will be equal to g minus of omega square. So a simple question that can come in ISEET in multiple choice questions is that where is the value of g maximum? So it is simply we can say that it is maximum at the poles, because if we take into consideration the rotation of earth, so the g is maximum there and it is minimum at the equator. So now we'll study about the gravitational field of a ring on its axis. Here we have a ring, and what we will do is we will break the ring into small masses, dm. All the whole of the ring can be broken down into small mass, and here we want to find out the what we want to find out the gravitational field. So we know that Ex, what is Ex? This will be Ex in this direction, electric field in this direction. We want to find out in terms as in direction of the center of this this ring. So Ex will be integration g dm upon z square cos theta. Cos theta is outside the bracket, that will come out to be g cos theta upon z square dm, and we know that that can be written as gm cos theta upon z square, because integration dm, that is this, and capital M is the mass of whole of the ring, so dm will be capital Gm. And we know that cos theta is nothing but x upon z. Cos theta is nothing but x upon z, right? And z is z by Pythagoras theorem, we can say that is equal to a square plus x square under root, right? So here we can substitute in this, we can substitute the value of cos theta and z square. So we get g capital M into x divided by a square x square to the power of 3 by 2, and Ey will be equal to 0. Why? Can you answer this question? Why electric field in the y direction will be 0? Okay, so the answer to this question is because if we take Ey here, that will be cancelled by the Ey here. How? See, if you take this dm, and if I take this dm also, so this dm will put an electric field in upward direction, while this dm will put an electric field in downward direction. So both will cancel each other out. Similarly, all the components on the ring will as in, if you take components on one side of the ring, that will cancel the components on the other side of the ring. Fine. So Ey will be equal to 0. So for now, these two topics I have covered in this video. There are some more advanced topic left, and that will be covered in the coming videos. Thanks a lot guys for watching. All the best.